Hello everyone, I'm Frank and welcome to Frank Puzzles, and this is today's hard level difficulty puzzle, and it's called Sum and Product Killer by Richard. And here are the rules. Apply classic Sudoku rules, which means fill the entire grid with the digits 1 through 9 without repeats in any row, column, or box. We also have the small numbers in the upper left corner of each cage, that is the dotted outline region, indicate the sum of the digits in that cage. An X between cells indicates that the two adjacent digits are multiplied when calculating the cage total. Within each cage, all digits must be different. For example, 14 can be formed by the digits, say we had 4 times 3 plus 2, or 9 times 1 plus 5, and this would satisfy these sets. So anytime you have an x, you have those two digits multiplied together, and they must add with the remaining digits, or the remaining sums. So anytime you have two digits crossed by an x, their contribution is not the digit themselves, but their product, and you add that to the rest of the products to add to the digit in the top left corner of the cage. And you cannot have repeats within a cage. Remember that. All digits must be different. There cannot be repeats. And those are all the rules. If you'd like to play along, there's going to be a link in the description. And now I'm going to get started. Let's go. Okay, we have here these digits. There's 9 distinct cells here, right? So that's one. Yeah, there's 9 distinct cells. All of these cells must be essentially in box 5 because they must be distinct. So this must be one of these 3. This must be one of these 4. This must be one of these 4. And this must be one of these 4. We have 4 multiplications and 1 additional digit, which is added to it. So that adds up to 69. That's going to be interesting. We also have 3 digits. 2 multiplied together plus 1 adds up to 48. And then we add another digit. So what is this 48 cage? It has to be the 2 digits multiplied together. Okay, so the 1 digit by itself can only be 9 at most. So that means the product has to be at least 39 here. Right? So it's 39 to 47 is the product. Well, 39 is 3 times 13, so that's out. 40 could be 5 and 8, but the problem is that if that's 40, we have 5 and 8, that's plus 8 would be 48. And you can't have repeats again within the cage. So that's out. 41 is not multiple, it's prime, so that doesn't work. 42 is 6 and 7. But the problem is that 6 times 7 plus 6 would have to add up to 48, and that's out. So we've eliminated 39, 40, 41, and 42. 43 is prime, so that doesn't work. 44 is 4 times 11, so that's out. 45 seems to be the only one that works. 45 would be 5 times 9 plus 3. That seems to be the only one that works. 46 is 2 times 23. 23 is not a digit, so that doesn't work. 47 would be is prime. So that doesn't work. This has to then be 5 and 9 with a 3. Right? So again, this is 5 and 9. This is 3. We have a whole bunch of 25s, so we need to figure out the factorization of those. That's going to be interesting. There seem to be multiple ones of those. This one specifically cannot contain 5 or 9. But not... Okay, so 5 and 9, two of them have to be outside. So they must be multiplied by something else. That's interesting. Okay. This cannot contain 5 or 9 for the multiplication. You could have a 9 on the outside. If you had... Okay. So you could have up to 9 on the outside. So this is 16 through 24 multiplied together. 16 would have to be 2 and 8. It could not be 4 and 4s because that would be repeated. 2, 8, and 9 works. Okay, so for 25, the possibilities are 2, 8, and 9. That could be a possibility. So 16 plus 9 is 25. 17 does not work because that's prime. 18 is 2 and 9 with 7. That works. So this could be... So we're looking at possibilities. 2, 9, and 7. Actually, would be... This would be 2, 9. And this would be 7. So 2, 8, and 9. But this can never be 2, 9 because we already have a 9 in box 5 from the 5, 9 pair. 2, 9, and 7 works. So that's 18 plus 7. So it's 18. 19 is prime, so that doesn't work. 20 is 4 and 5. But 4 and 5, 20 plus 5 equals 25, and you already have a 5 there. So 4 and 5 does not work. 21 has 3 and 7 with 4, so that could work. So 3, 7, and 4 could be a possibility, and it could be a possibility here. Right? 3 and 7 add up to multiply to 21, plus 4 is 25. 22 is 2 and 11. 11's not a digit, so that doesn't work. 23 is prime. 24 does work. 24 would be 3 and 8, or 4 and 6 with 1. So we have the possibilities 3, 8, and 1. Okay, well, this one can't be 3 and 8, but this could be 4, 6, and 1. Oops. I guess this would be... These would be 4, 6, and this would be 1. Or it could be 3 and 7? No, 3 and 8. Again, 3 and 8 and 1. So those are the possibilities for 25. That's a lot of possibilities. 14. That's going to be interesting. What are the possibilities for 14? You could have 1 times 5 plus 9. So for 14, we're going to list them out down here. 1, 5 with 9. 6 with 8. So 2 and 3, or 1 and 6 with 8. Ugh. This is going to be a lot. Okay, let's just do it all in the bottom row. So 1, 5, and 9. That 1 and 5 multiplied together, that's 5 plus 9. 6 could be 1, 6, and 8, or 2, 3, and 8. 7, so yeah, 7 would be 1, 7, and 7, but that would be a repeat, so that's not allowed. 8 could be 1, 8, and 6. So 1 times 8 is 8, plus 6 is 14. Or it's 2, 4, and 6. That works also. So we have 5, 6, 7, 6. 7 doesn't work. 8 twice. 9 is 1 and 9 or 3 and 3, but you cannot get 3 and 3. So it'd be 1, 9, and 5. 10 could be 2, 5, and 4. 11 is 1 times 11, so that doesn't work. 12 could be 2, 6, and 2, but that doesn't work because you have a repeat. Or it's 3, 4, and 2. And then 13 doesn't work because we have a repeat there. Or, sorry. 13 doesn't work because 1 times 13 would have to be the multiplication, and 13 is not a digit. Okay, so what do we have here? What are so these two are in the same box. So one side is always going to have a 1, and the other side always has a 2, right? Because each of these sets always requires either a 1 or a 2. This has a 2, this has a 2, this has a 2, this has a 2. These are essentially the same. So we have 168 as a triplet. So, okay, what are the possibilities for triplets, essentially? We have 159 and 168. Those are the ones. Okay, so those, we can clear those and clear those. What else do we have? We have 2, 3, and 8. 2, 4, 2, 3, 4. Okay. 2, 3, 4. 2, 3, 8. 2, 4, 5, and 2, 4, 6. Those are the possibilities for 14. So one of them's 159. Either way, 7 in box 7 has to be one of these 3 cells. We know that for certain. What about the 12? 13 is interesting. 15 is also going to be kind of interesting too. 20, we don't know. Okay. So 14, one of them's 1, the other one is 2. Do we have a guaranteed 3 or 4? No. For 25, okay, so what are the possibilities for 25? We have 2, 8, and 9. 2, 7, and 9. Ugh, I don't like doing it that way. Yeah. 2, 8, and 9. 2, 9, and 7. These are the only ones. 3, 7, and 4. 4, 6, 3, 8, and 1. 3, 8, and 1, and 4, 6, and 1. Those are the only ones, right? Again, 25, you could have 16 plus 9. So 17 is prime. 29 and 7. So, sorry, 2, 9, and 7, which is 18 plus 7. 19 is prime. 20 doesn't work because that's 4, 5, and 5. 21 works with 3, 7, and 4. 22 doesn't work because it's 2 times 11. 23 is prime. 24 could be either 3, 8, and 1 or 4, 6, and 1. Interesting. Okay. So this... Okay. What are the possibilities, essentially, here? So these are the 25s. These are the 14s here. So it cannot be 2, 9, and 7 here. It's 2, 8. It could be 3, 7 here. 3, 7, and 4. It could be 3, 8, and 1. It could be 4, 6, and 1. So this is 1, 4, and 9. This cannot contain a 3 at all. So these 3s are out. So this is either 2, 8, and 9, 2, 9, and 7, or 4, 6, and 1. Okay. This cannot have 3 be here, but that's still 1, 4, 7, and 9. This is also 1, 4, 7, and 9 because there's no restriction. And this is also 1, 4, 7, and 9. Okay. We have 12, so this is interesting. Okay, let's move these over here, essentially. So this is 2, 8, and 9, 2, 9, and 7, 3, 7, and 4, 3, 8, and 1, or 4, 6 with 1. Those are the possibilities for 25s. 12. 12 is going to be interesting. So you could have a 9 here. That would require this to be 1, 3. So 9 with 1 and 3 multiplied together. 8 would be 1 and 4 because you cannot have 2 times 2 because that's a repeat. 7 with 1 and 5. 6 would have to be 2 times, it could be 2 times 3, so that could work. So we're not guaranteed a, this could be 5 with 1 and 7. 4 with 1 and 8. It cannot be 2 times 4 here. 3 with 1 and 9, because it cannot be 3 times 3. And that's it. This can't be 3, though, so this can't be 9. So they're all 1 except for the 2, 3, 6. That's interesting here. That's for 12. 13 is actually pretty similar, right? You could have 9 here with 1 and 4. 8 with 1 and 5. 7 with 1, 6, or 2, 3. 6 here with 1 and 7. 5 with 1 and 8. Or 4 with 1 and 9. 5 could also be, yeah, this is too broad here. Interesting. This is 4 through 9. This is also, so this is 15. This has to be 6 through 9, right? Because if it's smaller than 6, that means, oh wait, that works. This could be 10. But okay, so if this is 5. Hold up. This 12 could be 2, 2, 5, but that doesn't work. And 1, 1, 11 doesn't work. Okay, so I forgot about the other possibilities here. Right, so this could be add up to 3, 4, 5, 6, 7, 8, 9. So 3 is 1 times 3. 4 is 1 times 4 because you can't have 2 times 2 in the same cage. 5 is 1 times 5. 6 is 1 times 6 or 2 times 3. 7 is 1 times 7. 8 is 1 times 8. 9 cannot, 1 times 8 or 2 times 4. But the problem is the other digit would have to be 4 to add up with that. So it has to be specifically 1 times 8. If you have 9, you have to have 1 times 9 because 3 times 3 duplicates in the same cage. If you have 10, you have 2 times 5, but the problem is that adds with 2 to add up to 12, so this can't be 2 times 5 here. And therefore 10 doesn't work. 11 doesn't work because that's prime. And therefore 11 is not a digit. Okay, for 13, 11 is prime, so that doesn't work. 10 could be 2 times 5 plus 3. That actually does work, so this could be 3. Ugh. And then 12, 11's prime. 12 works because you could have 3 times 4 plus 1 or 2 times 6 plus 1. So that doesn't help us very much. 15 could be a lot. Actually, the multiplication can't be very much. You can't have 5 times 9. So you could be 6 with 9. So then this is 9 with 1 or 6 or 2 and 3. 7 would have to be 1 and 7 plus 8. 8 would be 1, 8 or 2, 4 plus 7. That would work either way. 9 would have to be 1 and 9 because it cannot be 3 times 3, but that doesn't work because of the 9. 10 could be 2 and 5, but you can't have a 5 there, so that doesn't work. 11 is 1 times 11. That's prime. That doesn't work. 12 could be, this could be 3. And 12, it would have to be 2 and 6, which does work. 13 is prime. That doesn't work. 14 works. 2 and 7 plus 1. So that's fine. Oh, where is... I guess either one of them could be here. Okay, so we've got all the 15s there. One out of these 4 has to be 5, and one out of these 4 has to be a 9. We're not sure which is where. 20 is interesting, but it's pretty broad. 9 cannot be because that's with 11 prime. 8 could be with many things. So it has to be with 12. 8 could be with 2, 6, or 3, 4, but 3, 4 is not allowed in the multiplication. So 8 could be with 2 and 6. 12. 13 is prime, so that doesn't work. 14 would be 2 and 7, and then that plus 6 works. 15 would be 3 and 5, but that can't have a 3, so that doesn't work. 16 would have to be 2 and 8 multiplied together plus 4, which could work. That's 16. We have 17's prime. 18 is 2 and 9, but it would have to add with 2 to add up to 20, so that doesn't work. And 19 is prime. So these are all the possibilities for 20. That's actually interesting. So again, 2, 6 with 8. 2, 7 with 6. So if this is 2, 6, 8. Okay, so let's look at the possibilities. If this is 2, 6, and 8, the only possibility left would be 3, 7, and 4 here. Okay, so let's look at those. Okay, so 2, 6, and 8. So that's 12. This then has to be 3, 7, and 4, right? Because 2 eliminates these, 8 eliminates that, and 6 eliminates that. So it leaves 3, 7, and 4 remaining. 2, 7, and 6 leaves... Okay, again, yeah, so 11's prime, so that doesn't work. 12, we have that. We can't have 3, 4 times 4, so it must be 2 times 6. We can't have 13 because that's prime. 14 is 2, 7 times 6, so if we have 2, 7, and 6, that means this is 3, 8, and 1. So far, this is always 2, and this is always 3. What else do we have? We have... So that's 14. 15 would have to have 3 times 5, and we can't have a 3 here. 16 cannot be 4 times 4. It has to be 2 times 8, and then plus 4. So 2, 8, 2, 4. This would be 4 and 6, but that doesn't work because 2, 8, and 4 eliminates 2, 8, 9, 2, 9, 7, 3, 7, 4, and 3, 8, 1, and 4, 6, 1. So far, this is always 6 also. So that's 16. 17's prime. 18 would be 2 and 9 and 2. That doesn't work. And 19 is prime. So these are the only possibilities. 6 has to be here. 2 has to be here. 3 has to be one of these two. So this can never be 2 here. That's interesting. This is... So... The other set digit here is 7 or 8. The other digit here is 7 or 8. Okay, so let's... this is 2, 4, 6. This is 2, 4, 5. This is 2, 3, 8. This is 2, 3, 4. This is 1, 6, 8. And this is 1, 5, and 9. Or the 14s. Actually, we could do it here, I guess. 1, 5, 9, 1, 6, 8, 2, 3, 4, 2, 3, 8, 2, 4, 5. Okay. This then, one of these is 7 or 8. One of these is 7 or 8. We have a 2 guaranteed in this cage, a 6 guaranteed in this cage, and a 3 guaranteed in this cage. Therefore, we do not have 2, 6, 7, 8, or 3. So this is 1, 4, 5, 8. No, 1, 4, 5, and 9 here. Right? Interesting. So 3 is here, which means 3 has to be one of these 3. That doesn't tell us very much. Okay. We know this is 2, so this cannot be 2. So the 9 is only with 2, so this can never be 9 because that would require that to be 2. The 8, so this is 2, 8, 2, 9. It cannot be 3, 7 or 3, 8. So this can't be 8. This is either 2 here, with this being 9, or 2, 8, and this is 4 and 6. As possibilities. We have to reach 69 for the digits 1 through 9. And 5 must be multiplied and 9 must be multiplied. I think we have to solve that, right? Box 3, we already have some interesting stuff. Box 7, we also have some interesting stuff. One of these has to be 1, and the other one has to be 2, essentially. One has to be one of these 4 digits, because it must be 1 times something plus the other one. 2 does not have to be the multiplication, though. So 2 could be any of these 3. 2 could be any of those 3, right? Because I think one of them's 2, 4... adds up to 14. 2 and 3, 4. That was it. 2 could be added to 3, 4. Okay, this is 1479, 1479. So this cannot be 1. Interesting. Hmm. Okay. That's interesting. If this is 2 and 3, that means this has to be a 4-6 pair. So if this is 2 and 3, that would be 6. 2 and 3 multiplied together is 6, plus 6 is 12. This would have to be 4 and 6. 4 and 6 would have to be with 1. This could no longer be 1. This could no longer be 2, 3, 4, or 6. It would have to have a 7 or 8 here. So far, that seems kosher. It could be 7 with 3 and 4, or 8. It cannot be 8, 3, 1. It would be 8, 2, and 1. Oh, that's interesting. Sorry, 8, 2, and 9. So if this is 4, 6, and 1, that's a good question. What does that make this? 4, 6, and 1 forces this to be 4 and 3, 7. This 7 means this can't be 7, so this is 2, 6, and 8. So if this is 4, 6, and 1, that leaves us as 4, 3, 7, which forces this to be 2, 6, and 8. So this cannot be 6. This cannot be 4 then. This can't be 6 because this would be 2, 6. This can't be 4. So this is 2 or 6 no matter what. Right? The only reason this is 4 and 6. So the only way this is 4 and 6 is if this is 4, 6, 1. That makes this 4, 3, 7. That 7 eliminates 7 here. So this is 2, 6, and 8. That 6 would eliminate that 6, which would make that not 4. So it's either 2, 8 with 9, 2, 9, 7, or it's 4, 6, and 1 here. Okay, that's interesting. This could be 2, 8, 9, 3, 7, 4, 3, 8, and 1, or 4, 6, and 1. Huh. That's a wide variety. Hmm. Okay. Hmm. So this can never be 2 here. Neither can this can't be 2 or 3. Actually, what are the oh. Huh. So, if this is 2 and 8, this would be 2, 8, 9. If it's 2 and 9, this would be 2, and that's 9. And this is 7. If this is 3, 7, it has to be 3, 7, 4, 3, 8, and 1. 4 and 6 could be either of those. We know 6 has to be one of these 3. But this could be 6. What does that mean? I'm not sure. So this is specifically 2, 3, 4, and 6. That doesn't tell us much, though. Seven. We know 5 and 9 are outside. If we have another outside, okay. It can never be 7 times 9. Because 7 times, or 8 times 9, right? If we have 7 or 8 times 9, that would be 7 times 9, 8 times 9 is 72, and that's already greater than 69, so that doesn't work. 7 times 9. What are the multiplications right now? Okay. You can only have 1, 1. You could have a 2 somewhere. So 1, 1 means that... Huh. Where is a 9 multiplied together is kind of the question, right? Hmm. What else do we have? What are the minimum multiplications? Maybe that would be best. Or sorry, yeah, what are the minimum multiplications? We have 8 digits multiplied together. 9 has to be multiplied with something. So that would be minimum 9 times 1. You could have 8 separate from each other. So that would be separate. We have 8. So minimum is 1 times 9 plus 8 plus 2 times 7 plus 3 times 6 plus 4 times 5. That's the minimum. Right? Because we want to minimize every digit that's highest. 9 would be multiplied by 1. 8 would be by itself. 7 would be multiplied by 2, because if we have 7 times 3, that 7 is multiplied is added one more time when a smaller digit could be added. So therefore 7 multiplied by 2. So that's 9 plus 8, 17. 2 times 7 is 14. So 17 plus 14 is 31, right? Um, 2 times 7 is 31. 3 times 6 is 18. 31 plus 18 is 49. And 4 times 5. So this has to, okay, that has to be the case then. This has to be 8. This cannot be 8 anymore. We have 5 in one of these and a 9 in one of these. And the rest are, so this cannot be 8 anymore. So this can't be 2, 8, and 9. This is 4 and 1. So this cannot be 2. This is either 3, 7, or it's 4, 6 here. It cannot be 3, 8. It cannot be 2, 8. So it's 3, 7, or it's 4, 6. But the 5 outside, so this is the minimum again, adds up to what this 69 is. So therefore it must be the minimum. Therefore this is 8. We have a 9 outside multiplied by 1. We have a 5 outside multiplied by a 4 inside the box. So therefore the 4 cannot be inside the box. Therefore this is a 3, 7 pair, which eliminates 3 and 7 inside the box. That leaves, this 3, 7 must be with 4. So this is 4. Therefore 4 cannot be here. 4 has to be one of these two, which means 5 must be multiplied together with it. We have 3, 7 on the outside. 3, 7, 9. The 3, 7, 9. This can't be 3, so this is 7 or 9. This is 3, 7, 9. This cannot be 3. It's 7 or 9 here. So 5 is one of these, multiplied with the 4. That's 20. Then we have 3 multiplied with 6. That's 18. So it's 38. 7 outside must be multiplied by 2. That's 14. So 20 plus 18 is 38 plus 14. 38 plus 14 is 52. Plus 8 is 60. Plus 9 times 1. So any of these could be 1. Is, right, is, we have then, right, so 4 has to be one of these two. 4 actually then has to be one of those two. This is 5 and 9. This can no longer be 8 here. That's interesting. These cannot contain a 4. So this is 4. One of these is 3 and 7. So this is 3, 7. That eliminates 3, 7, 3, 8. You could have 2, 8, and 9. 2, 9, and 7. It cannot be 3, so this 4 is out. But it could be 4 and 6 here. 4, 6, and 1. This cannot be 4 here. So what possibilities are there? It could be 1 times 3 plus 9. Okay, this can no longer be 8 either because of this 8. These can't be 4. So again, to add up to 12, you have 1 3 times... Okay, so let's go through them again. This is 9 times 1 and 3. That seems okay. So this is 3 plus 9. This could be 4, but it would have to be 1 times 4 plus 8, which doesn't work because we have a 4 in the box. 1 times 5 plus 7. That works. So far, 1, 3, and 9 means 9 cannot be here. 1, 5, and 7 means this has to be 9. You could have 6 plus 6. That would not be 1, 6. It would have to be 2 and 3 and 6 here. So that's not a guarantee. This would have to be 9. 7 could be here. 1, 7, and 5. And 8 could not be here. Because, again, you have to have 1, 8, and 4 to add up. And that doesn't work. This can't be 8 anymore. So this is specifically 2, 9, and 7. And 4, 6, and 1. Okay. The 1 has to be here as 1 and 9, or it's 2 and 7. So this is 1 and 7. This is 1 and 7. That eliminates 1 and 7 in the rest of the column, which means this can't be 7. This must be 3, which makes that a 7. So these can no longer be 7, which means this can no longer be 5. This 3, this is also eliminated from the 1 and 7 because one of these is 1 or 7, this is 1 or 7, so this cannot be 1 or 7. So this can't be 1, this can't be 9. We have a 2, 6 here. This is 3 and 4. So 3 has to be one of these 3 digits. So again, it could be 1, 3, 9. This could be 7, 1, 5, or 6, 2, 5. We can't have 1, 7 here and 5. We can't have 1, 8, and 4. Can it be 1, 9, and 3? No, because that's a 3. Can this add up to 10, 2, 5, and 2? Nope, that's a repeat. 11 is prime, and so these are the possibilities. Okay. This is 3 and 7. This cannot be 3 or 7 here. Okay, that doesn't tell us much. 9 could be any of these. 1 has to be one of these. That means, okay, so since one of these is 1 or 7, this is 1 or 7, one of these 2 digits is a 7. So we know 7's here. 7's here. 7 then has to be one of these 3 digits. Okay, that's pretty broad. If this is 3, 6, or this is 2, 7, that's interesting, actually. So this is 2, 8, 9, 2, 9, 7. It cannot be any of the 3s, or it's 4, 6, and 1. Right? This is... If this is 3, 7, or 2, 6, obviously this becomes the other pair, which would force this to be 1, 9, and 1, 9. That is possible. If this is 1, 9, that makes this 7, this 3, and this has to be 2, 6. Sorry. If this is 1... Oh, that's interesting. If this is 1, 9, that forces it to be 7. That forces this to be 3. But then that would break that situation. So this can never be 1 and 9. We know 1 and 9 has to be either here or here. Okay. Where is the 8 in row 3? Cannot be any of these cells anymore. Cannot be here. It has to be one of these two digits. So that one of these two is an 8. So this could be 2, 8. It could be 3, 8. Those both work. Oh, actually, how does this work? So it's either 2, 9, and 7, which breaks. So if this is 2, 9, and this is 7, that means this cell doesn't have a possibility. So it cannot be 2, 9, 7. It has to be 4, 6, and 1. So this is 4, this is 6, this is 1, which means this can't be 1. This is 2 and 7. This has to then be 6 and 3, which means this can't be 6 and 3. This can't be 2. This is 4 and 5. 3 cannot be here. One of these is 7. This can't be 2. This can't be 3 here. This can't be 2. So it cannot be 2, 8, and 9. So this can't be 9. This can't be 7. This can't be 4. It's 1. So it's either 3, 8, and 1, or it's 4, 6, and 1. So this 6 means this can't be 6. This is an 8, so this has to be 2 and 6 multiplied together, which means this cannot be 8. This is 3, 7 multiplied together, and therefore this is a 4. So this is 3, 7, 4. This is 2, 6, 8. These cannot be 4 anymore. Cannot be 4. This can't be 1 because of the 1 here. This can't be 6 or 4. This has to be 8. So this is 3, 8, and 1 added together. So 3 times 8, which is 24 plus 1. 4, 3, 7. This one means this has to be a 5. This cannot be 8. This is 5 or 9. This can't be 1. Where is the 1 in box 3? It has to be here. So this is 1, which means this cannot be 1. This can't be 1. This can't be 8. And this can't be 8. This can't be 3. That's interesting. This can't be 8 here because of this 8. There's no 3 involved. It could be 4, 6, 1. Okay, so the remaining digits in row 5 are 1, 2, 7, 9. This is interesting. So this adds up to 15. You can have, again, 9 plus 1 times 6. Okay, yeah, let's go through the possibilities again here. So it's 9 with 1 times 6. 7 works, or 1 works here. So as a 7, that would require this to be, okay, if this is 7, that specifically has to be 1 and 8, I believe. It can't be 2 and 4 anymore because there's a 2. And if this is 1 and 8, this cannot be either. So that doesn't work. So 7 does not work. 1 would have to be with 2 and 7 here. But that doesn't work because we have a 2 already in the row. Because this would be 14. So that has to be 2 and 7. So the only one that works is 9 with 1 and 6. This cannot be 1 or 9. These can't be 9, obviously. 1 has to be one of these two. This is 6. The remaining digits in this 6 eliminates this 6. So this is 2. This is 6. This cannot be 1 or 9. This can't be 1 or 9. So this multiplies together and has to multiply to... This can't be 6. What are the possibilities here? You can no longer have it multiply with 1. And this 9 eliminates that 9, so this is 5, which makes that 9, which makes that a 5. Therefore, you have 2, 3, 2, 4, and that's it. 2, 7 multiplies to 14. So either way, you have to have a 2. So this is 2, and it has to be with 3, which could be here, or 4. If you have 2 and 3, that's 6 plus 7 adds up to 13. If you have 2 and 4, that's... This can't be 2 or 4, so this is 1, this is 9. So this can't be 9 here. This can't be 9. So this cannot be 1 and 3 here. It's 1 and 5, or it's... So this can't be 4. Okay, so we still have these, which we can clear out if we can figure this out. We have a 1 and a 7. So it cannot be 2, 8, 9. It could be 2, 9, 7. Cannot be 3, 7, 4. So there's no... Oh, well, there's no 7. Yeah. So we have 2, 9, and... Oops. 2, 9, and 7. We have 3, 8, and 1. We have 4, 6, and 1 as the possibilities now for the last 25. This 9 means this can't be 9, so this is 5, which makes that a 9. One of these is 2. This can't... Wait, no, this can't be 3, 8, because there's no 3. So this has to be, then, 2, 9, and 7, or 4, 6, and 1. Those are the only possibilities, because we have 1 and 7 left. We do not have a 9 here. The remaining digits in row 4 are 4, 7, and 8. Well, one of these 3 digits must contain a 7 or 4. So 8 has to be one of the cases. So this cannot be 8. One of these is 4 or 7. One of these is 4 or 7. That eliminates 4 or 7 in the rest of the box. Therefore, this must be 8, which means this can't be 8. This can't be 4 because of that 4, so this is 7, which means this can't be 7. This becomes a 4, 8 pair, which eliminates 4, 6, and 1 as a possibility. Therefore, this is 2, 9, and 7. So this 2, 9 eliminates 2 and 9 here. That can't be 2. So this is 1. This can't be 7, so this is 2, which makes that a 4. Therefore, it's just 2, 4, and 2, 4 multiplied together is 8, plus 5 means this is 13. Okay, so these, we don't need the 25s anymore. Okay. Remaining digits in row, this has to be a 6. And these are 5 and 8, but wait, that doesn't work. We have a 5, 8 pair here. Ooh, that's bad. What did I miss here? Dang it. I don't know if I want to go through all this again. I might have to, though. I don't know where I messed up. That's kind of the issue. Okay. Okay. Right, we do know 8 has to be in the middle, because 8 multiplied by something would be too much for 69, to add up to 69. Even if you had 2 times 8, you had 7 separate. 9 has to be outside, so 9 has to be multiplied. So we have 9 times 1. If we have 2 times 8, that's 16. 7. 16 plus 9 is 25. 7 is 32. 3 times 6 would be 18, so it's 50. 4 times 5 would be 70, right? So this has to be 8 here. You cannot have 2, 8, and 9. You can't have 2, 9, and 7. You could have 3, 7, 4. You cannot have 3, 8, and 1. And you can't have... The 5 is outside, so the 4 cannot be there. So this has to be 3, 7, and 4. You can't have 8 again, because 8 has to be in the middle. Maybe it was this part. Oof. This 8 eliminates a lot of stuff, though. This is 3 and 7. This cannot be 2, 9, and 2, 8, and 9. It could be 2, 9, 7. It can't be 3, 7 because one of these... That would eliminate all possibilities for that cell. Can't be 3, 8. It could be 4, 6, and 1. So those are the only possible ones left. If this cannot be 4 anymore... So we know the remaining digits are 1, 2, 4, and 6. 6 must be multiplied by 3. So this can't be 6 and 3. The 4 is eliminated here. Therefore, it's 1 and 9 or 2 times 7 here. The problem is, if this is 2, 9, 7, that eliminates all possibilities for that cell. So this cannot be 2, 9, 7. Therefore, it's 4, 6, and 1. We know then this is, that 1 eliminates that 1. So this is 2. It must be multiplied by 7. Which means this cannot be 1? Why can't... Oh, this can't be 1 because of the 1, 7 pair here. So this must be 6 and 3. Which means this can't be 6 and 3. It can't be 2. So it's 4 times 5. So again, that's 20 plus 14 plus 18, right? We have 20 plus 14... 34 plus 18 is 52. Plus 1 times 9 is 9. 61 plus 8, 69. So that works. This can't be 3. That can't be 3 or 2. No 2 there. So this is either 3, 7, 4 or can't be 4. It has to be 4, 3, 8, 1 or 4, 6, 1. Either way, it's a 1. Right? This can't be 6 anymore, so this is 8, which with add together has to be 2 and 6. This can't be 8 anymore. This is 3, 7, and 4. This is 1, 5, 9. This can't be 1. This can't be 4, 6, so it must be 8 and 3. That's 5 and 9. 5 and 9. Where's the 1? It has to be here. Okay. This is a lot of stuff left. Okay. Okay, maybe this part is the error. So again, we could have 1, 6, and 9. So 6 added up with 9. You can't have 7 added up with 8. You could have 8 with 7, but it needs to be 1 times 8 or 2 times 4. Well, this can't be 1 or 8, so this can't be 1 times 8. And the 2 eliminates the 2 times 4. So this can't be 8 plus 7. Can this be 9 plus 6? No, because this is 6 here. Can it be 10 plus 5? No, because this is 5. Can it be 11 plus 4? No, because that's 4. Can it be 12 plus 3? No, because that's 3. Can this be 13 plus 2? No, because 13 does not multiply. It's prime. 13 is prime, so you can't multiply it with 2 digits. 14 requires a 2 and 7, so this can't be 2 and 7. Nope, so this is 169. We definitely know this is 169. Therefore, this is 2 times 6 there. This has to be 5. That's 9. This is 5. 2 times 3, 2 times 4. You cannot have 2 times 1. You can't have 1 times anything. Oh, you could have... well, no, 3 times 4 requires a 1 here, and that's not allowed because of that 1. So it has to be 2, guaranteed here. Okay, 4, 7, 8. This cannot be 2, 8, and 9. Ugh. This has to be 4, which means this is 2 times 4 plus 5, but the problem is this can't be 5 or 8 then. Did I miss a sum and product killer here? It feels like I did, but I don't know what it is. Dang it. Okay, so this we know for certain is the case, right? This is the minimum we can have. We have 1 times 9, 1 times an 8, 2 times 7, 3 times 6, 4 times 5. That's the minimum you can have. Because every largest digit, you want to have the minimum amount of multiples there. So that's 1 times 9, 1 times 8, 2 times 7, 3 times 6, and 4 times 5. And that adds up to exactly 69. So that's guaranteed. 48, I'm pretty sure has to be that way. 30, again, you could have a 9 here with 39, but that's 3 times 13. That does not work because 13 is not a digit. 40 would require 5 times 8, and you have to add 8 to that, so that doesn't work because you have a duplicate 8. 41's prime. 42 is 6 times 7, but you have to add 6 to it, so it's duplicate 6. 42 doesn't work. 43 is prime. 44 is 4 times 11, which is not a digit. 45 has to be 5 times 9 plus 3. 46 is 2 times 23, which is not a digit. 47's prime. So it has to be 593. We know that for certain. It's 593. The 8 then the 9 has to be outside and must be multiplied by 1. Because all of these outside digits of outside of box 5 has to be multiplied by 1. The 8 then has to also be 1 singular, so this has to be 8. Am I missing a 25 pairing? That's the question, right? This 5 and 8 problem. Maybe, no, it still has to have a 2, right? You can't have 2 times 2. So no 2 times 2 is 9. Anyways, this is 9. 5 cannot be here. 5 can't be here because that would have to be 4. 4 can't, yeah. So this is 3, 7, 4. Am I missing a 25? That's the only thing I could think of that would basically that would make this not the way it is, right? So this has to be the way it is. Okay, let's try that again. 25. You can have 9 added to it. You can have 9 added to it, so it's 16. You can't have 4 times 4. It can only be factored out to be 2 and 8. So that works 2, 8, and 9. 17 is prime, so that doesn't work for the multiplication. 18 can be 2, 9 with 7. That works. 19 is prime, so that doesn't work. 20 has to be 4 times 5 because 2 times 10 doesn't work. 2 is not a digit. 4 times 5, but you would have to add 5 to it, so that doesn't work. So we have, again, 2, 9, 2, 8, 9. 2 times 8 plus 9. 2 times 9 times plus 7. That's 16, 18, 17, 19 doesn't work. 20 doesn't work. 21 is 3 times 7 plus 4. That works. 22 is 2 times 11, so that does not work. 23 is prime. 24 can be 3, 8 plus 1. 4, 6 plus 1. Sorry, 24. It cannot be 2 times 12, because 12 is not a digit. So again, 4 times 6 or 3 times 8 plus 1. And those are the only possibilities. But we have this is broken here. Because this cannot be 4. So 4 has to be one of these two digits, which means this cannot be 4. So, okay, I've double checked the 25s. Those are all kosher. Again, 2 has to be here because you cannot have 3 multiplied together. Okay, what are the 20s? Again, 11 doesn't work from the multiplication because that's a prime number. 12 does work. 2, 6 times 8, but we know this is 3, so it cannot be 3, 4. So it's 2, 6 specifically times 8 together plus 8. 13 doesn't work because it's prime. 14 could be work. 2, 7, and 6. That's fine. 15 doesn't work because it requires 3 times 5, and we cannot have 3 multiplied right now. 16 could work. 2, 8, but then it would have to be 4 here. This. What did I mess up? I messed something up. I'm not sure what. I'm pretty sure all the 25 sets I have, the 14 we haven't even used. So I'm sure the 25 sets are correct. I'm pretty sure the 69 is correct. The 25, again, there's only certain things we can have. Okay. Let's get the 25 sets back so that we can make sure we're doing things correctly, at least. Maybe this 20 and 30, 25 set is problematic. Okay, let's start when we have the 8, right? Okay, we have... The 9 has to be outside in the cage. Outside box 5. We know for certain this has to be 3 times 5. 5 times 9 plus 3. Because no other one works. Again, just to reiterate, just to make sure we're clear. 39 doesn't work, so this can't be, because that's 3 times 13. And 13 is not a digit. 40 doesn't work because that's 5 times 8, and we need a 8 added to it. So that would have repeat 8s. 41 is prime. 42 is 6 times 7, but it has to add with 6 to add up to 42. Sorry, 48. So that would not work. 43 doesn't work because it's prime. 44 is 4 times 11. 11 is not a digit. 45 is the only one that works. It's 5 times 9 plus 3. 46 is 2 times 23. 23 is not a digit. 47 is prime. So it has to be 3 times 5. 3 plus 5 times 9. So 9 has to be on the outside, which means it must be multiplied by 1. 8 has to be also singular. So therefore, we are guaranteed this has to be 8. Okay, this cannot contain any of the 3's. It cannot be 2, 8 anymore. So this has to specifically be 2, 9, 2, 9, plus 7, or 4, 6 plus 1, right? This 20, I think, is very limited also. So it cannot be 11. This product cannot be multiplied by 11 because that's prime. 12 cannot be 3, 4. It has to be 2, 6 plus 8, which works. 13 is prime. 14 can be 2, 7 plus 6. That works. 15 requires 3 times 5, and that you cannot have 3 here. 16 could be 2, 8, and 4. But 2, 8 eliminates 2, 8, 9, eliminates 2, 9, 7, it eliminates 3, 7, 4. Sorry, 2, 8, 4 eliminates 2, 8, 9, 2, 9, 7, 3, 7, 4, 3, 8, 1, and 4, 6, 1. So 2, 8, 4 does not work in this scenario. 17's prime. 18 would be 2 times 9 plus 2. Therefore, you would have a repeat, so that doesn't work. And then 19 is prime. So we guarantee a 2 has to be here. A 6 has to be here. This cannot contain 2 or 6. It must be either 3, 7, 4 or 3, 8, 1. That's guaranteed. If this is 2, 9, 7 or it's 4, 6, 1. If it's 4, 6, 1, that means this would be 4. So this could not be a 4 here, and this would have to be 6. So it's 4, 6, and 1. This has to be a 2, so this cannot be 2 here. So this can't be 9. This can no longer be 8. So 2, 8, 9 is removed as a possibility. We can have 2. You cannot have 2, 9, 7. You could have 3, 7, 4. You cannot have 3, 8, 1. So the possibilities here are 3, 7, 4, or 4, 6, 1. Well, the 5 must be multiplied by a 4 inside. So this cannot be 4 and 6. This has to be 3, 7, and 4 then. We know then the insides are 1, 2, 4, and 6. And they must be multiplied with 3, 5, 7, 9. Well, neither of these can be 4. The 4 must be multiplied with a 5, so this can't be 5, this can't be 5. This can no longer be 3 because of that, therefore this can't be 6. This can't be 3, so this can't be 6 here. This is either 2 times 7, or it's 1 times 9. Either way, there's a 1 or a 7 here, which eliminates 1 and 7 in the rest of the column, because this must be 1 or 7. So this can't be 7, this must be 3, which makes that a 7. This can no longer be 7 here. This cannot contain a 4. This can't be 4. This can't be 1, because either this is 1, 9, or this is 2, 7, which would make that the other 1 or 7. So this cannot be 1, which means this can't be 9. If this is 2, 9, and 7, that eliminates all possibilities for that cell. So it cannot be 2, 9, 7. It has to be 4, 6, 1. Which means this can't be 1. This is 4. This can't be 6. This is 8. This has to be 3, 7 multiplied together and with 4. So this can't be 4. This can't be 4. This can't be 4. These can't be 7. This is a 2, 6 pair here. This is 1, so this can't be 1. This is 2 then, which must be multiplied by 7, not 9. Must be 7. This can't be 4 or 7 here. This can't be 2. This can no longer be 9, 2, 8. This can't be 1. This can't be 4, 7. This has to, if this is 9, this would have to be 8 and 2. But this is a 2, so this can't be 2, and this is a 2, so that can't be 2. This can't be 2. This is 6 times 3, so this cannot be 3 times 6 here. We can't have a 7 anymore in this. No 7 and 2. So this is 5 and 9. This is 5 and 9. Maybe this is where I messed up. 3 and 8. No, maybe. I don't know. This can't be 8. This is 8. This can never be 9 anymore, so this has to be 1. It's 3, 8 or 4, 6. This can no longer be 1. This cannot be 4 or 6 because of the 4 here and the 6 here. So this has to be 8, which makes this 3. 3, 8, and 1. That forces this to be 5 and 9. There's no other place for 1 here. So this is 1, which means this can't be 1 here. Yeah. So far, okay, so we have a 5, 9 pair, a 1, 4 pair here. Maybe it was this. This is problematic, maybe. Okay, so maybe that was the assumption I made. That was incorrect. Anyways, okay. Can't be 3, 7. Possibilities for here. This could be 6 and that's 9. That's possible. So it would have to be 1 and 6. And this is 9. 7. 1, 7, 8. But this can't be 8, so that doesn't work. 8 plus 7. That could technically work, except that we have a 1, 8 here. So this cannot be 1 or 8 here. And therefore, this can't be 1 times 8. Can't be 2 times 4 because of the 2 here. So that was okay. That was 8 here and 7 here. We could have 9 here, but that would have to be 1 times 9. It cannot be 3 times 3 because that would be duplicated. So that doesn't work, and that 6 can't be here. 10 doesn't work because 2 times 5 plus 5, and that's a duplicate 5. 4 doesn't work here because... Why doesn't that work? 4 doesn't work here. Oh, no. So, yeah, this still has to be 4 times 5. Okay. 11 can't be here because that's prime. 12 cannot be 2 times 6, cannot be 3 times 4, so that's eliminated. And therefore, we have to have 3 here. 13 is prime. 14 is 2 times 7, and you can't have a 2 here. So that leaves this. This has to be 1, 6, and 9. Which means this is 5 times 4. This is 1 times 9. This is 5 and 9. This cannot be 5 or 9 here. This can't be 8. This can't be 1 multiplied together. This 6 eliminates that 6, so this is 2, this is 6. This 9 eliminates that 9, so this is 5, that's 9. Again, the possibilities are 2 times 3 and 7. This can't be 3. Or 2 times 4 plus 5. The remaining digits in row 7 are 4, 7, and 8. But this cannot be 4, so 4 has to be one of these 2 digits here. This can't be 4 or 9. This cannot be 4. It cannot contain a 3. So these are out. Can't be 4. It must contain a 2. It cannot be 2, 8, and 9. It has to be 2, 9, and 7. So this can't be 7. This can't be 7. That's 4, 8 pair, which makes this a 7. This 2 means this can't be 2, so this is 1. That's 2. This can't be 2 here. Okay, let's just do remaining digits. Oh, it could be 2. No, but 5 doesn't work. That's why. 5, 4. Okay, this can't be 4, so 4 has to be one of these. We have 4, 5, and 8 remaining here. This can't be 8. This can't be 5. This can't be 4. This has to be with 6 remaining here. This 9 eliminates that 9. This is 5. What am I missing here? This is irritating. 3 and 4 multiply together, but you have to have a 1 here. 8 doesn't work. This 7 means this can't be 7, so this is 3, this is 7. That's 3 in the corner. We not celebrating because I'm not sure why this keeps breaking. 1 times 6 is plus 9 is 15. Did I miscalculate something? Maybe. Okay, 3 times 7 is plus 4. 21 plus 4 is 25. 2 times 6 is 12 plus 8 is 20. 6 times 4 plus 24 plus 1 is 25. 5 times 9 is 45 plus 3 is 48. 8 times 3 is 24 plus 1 is 25. 2 times 9 is 18 plus 7 is 25. 6 times 1 is 6 plus 9 is 15. This can't be a 1, so we have... This could never be 8 because it has to be 1 times 4. It's this. This 13 cage breaks, essentially. What? Where did I go wrong? Where am I messing up here? Yeah, 1 times 9 is 9, plus 8 is 17, plus 2 times 7 is 14, 31. 31 plus 18 is 49. 49 plus 20 is 69. 3 times 7 is 21, plus 4 is 25. This, I mean, the problem is this can't be 4 and 5, right? 4 times 2 plus 5. It can't be 4 times 3. It can't be 2 times 8 or 3 times 8 unless you have a negative here. I mean, yeah, that's just not going to fly. So where is it breaking then? Why isn't this working? This is frustrating. I've double-checked the 25 possibilities. Triple-checked them, in fact. Those are the only possibilities there. I double-checked this. I double-checked this. I double-checked this. The 69 is the minimum required. The 48, I've triple-checked. I'm not even using the 14s yet. So why is this breaking here? Because this can't be 2 or 3. So it can't be 2 times 3 plus 7. I tried to avoid assumptions here. The 5 definitely has to be multiplied by the 4, so that eliminates 4. 4 has to be inside to be multiplied with the 5, right? Because 5 cannot be here. It must be outside, which multiplies with 4 inside. So this cannot be 4. You can't have a 2. Why can't you have a... Because... Why can't you have a 2, actually? You can't have 2, 9. Oh, the 8 has to be inside. So it can't be 2 times 8. Cannot be 2 times 9, because the 9 has to be here. So it has to be 3, 7, 3, 8, or 4, 6. But the 4 has to be inside because the 5 is outside. And it must be multiplied with the 4. So then this cannot be 3, 8 anymore. It's 3, 7, and 4 guaranteed. Again, this has to be 2, 8, 2, 9. It can't be 8 anymore because this has to be 8. This is 5 or 9. So it could have been 2, 9. It could have been 4, 6. The thing is, it can't be 3s. So it has to be... It can't be 2, 8 anymore. So it's 2, 9, which makes that 7. Or it's 4, 6, which makes that 1. Either way, this is 1, 2, 4, 6. The 2... The 4 cannot be here. If this is 6, it's multiplied by 3, but the 3 can't be here. So this is 1, 9, or 2, 7. If this is 2, 9, and 7, that eliminates all possibilities for that cell. So it cannot be 2, 9, 7. It has to be 4, 6, 1. Which makes this 2 times 7. This cannot be 1 anymore. It can't be 2. It can't be 4. This has to be 6 times 3. This has to be 1, 6, and 9. That's the only possibility that works. That makes this 4, 5. That makes this 1, 9, which makes that 5, which makes that 9. This cannot be 4. Right. We tried... You cannot have a 3 as a multiplication here. 2, 6, and 8 works. 2, 7, and 6 works. You cannot have a 3 multiplied by anything. So you can't have 3, 6, and 2 for 18. Shoot, I did miss one. I did miss one. Okay, that's the reason why it breaks. I missed one here. This is 3, 6, and 7 also. Oh. Oh, that sucks. Okay, so I did miss a 25. That's the reason why it breaks. Okay. Well, at least now we know. Okay. So, I missed a very important 25 possibility, which was 3, 6, and 7. Okay. Well, there you go. Okay. Where do I start then? Okay, we don't... Okay. Dang it. Missed the factorization. So this could also be 3, 6, and 7. Okay. We know the method of solving this then. So, what are the possibilities again? This is still... Okay, so these I think are still the same. This could be different. So again, for the 20, you cannot have 3 times anything. You cannot have 11 as a multiplication because 11's prime. 12 works, 2, 6, and 8. 13 is prime. 14, 2, 7, and 6 works. 15 doesn't work because it at least be 3 times 5. And we can't have 3 multiplied. 16 could work. Okay, so this could be 2, 8, and 4. So we are not guaranteed this is 6. Okay, so that's going to be interesting. 17's prime. 18, 2, 9, and 2 has a repeat 2, so that doesn't work. 19's prime. So this always contains a 2. We know that for certain. Therefore, it cannot contain a 2 here. It could be 3, 6, 7. Ooh. 3, 7, 4, 3, 8, 1. It cannot be 4, 6, 1. Because if it's 4, 6, 1, that would make this 8 and this 2 times 7, and that does not add up to 22. So we know the 3 does have to be here. This then has to be 2, 8. So again, okay, so similarly, we still know the 8 has to be in the middle, right? Because we know that 9 has to be outside. It must be multiplied by 1. And to add up to the minimum, it has to be 8 is multiplied by 1. But we can't multiply any other 1 by 1, so 8 has to be in the middle. So this is 8. This cannot be 2 and 8 here. So it could be 2, 9. It cannot be any of the 3s, and I missed the 3, 6, which is very important. That's really bad. It could be 2, 9, but this has to be 2 multiplied together, so this would be 2 and 9. It could be 4, 6, and 1. So this is 4, 6, 4, 6. This is 1. So it could be 2, 9 with 7 or 4, 6 with 1. All the 3s are removed. It cannot be 2, 8 because the 8 would have to be multiplied together, and that can't work. So this has to be 8. Oh, man. This is a lot. Okay. So it cannot be 2, 8. It cannot be 2, 9. So all the 2s are gone. The 5 has to be outside, so it must be multiplied by 4. So this can never be 4. It can't be 3, 8. So this is 3, 6 or 3, 7. Well, if 3 and 6 are both inside, are both here, that would mean that the 3 and 6 would both have to be outside, multiplying with something else. But then that we do not have the minimum amount necessary to get to 69. So this does have to be 3, 7, and 4. So this is still correct. So we have 3, 5, 7, 9 outside. And it's multiplied by 1, 2, 4, 6 inside. This is still the same. This cannot be 4, so these cannot be 5. This can't be 3, so this can't be 6 here to multiply together. One of these is a 1 or a 7. One of these is a 1 or 7, so that's still the same. Therefore, this can't be 7. This is 3. This is 7. This can't be 1, so this can't be 9 here. Again, if you have 2, 9, and 7, that would eliminate all possibilities for that cell. Therefore, this is a 4, 6, and this is a 1, which means this can't be 1. This is 2 times 7. This can't be 2 times 7. Therefore, this must be 6 times 3. This can't be 2 or 6. This can't be 2 or 6. This can't be 3 or 7. This can't be 3 or 7. So we have a 5, 9, 5, 9 pair. This can't be 5 or 9. Can't be 4. This can't be 7, 8, or 4. If this is 8, this would have to be 1 times 4, which is not allowed to be. So it's either, this is still the same. Okay, that's all kosher. This still cannot be 2, cannot be 3 here. This can't be 8, so this, I think, still has to be 1, 6, 8. This can't be 7 anymore. So because of that, this is either 2, 6 plus 8, or 2, 8, 2 times 8 plus 4. So this has to have an 8, which means this cannot be 8. This can't be 1 either. So it cannot be 3, 8, and 1. So 8 is removed from here. This is either... Okay, so this we don't know. So it cannot... This is 2 and 8. So it's either 2 times 6 plus 8 or 2 times 8 plus 4. So either of these have to be 8. This could be 3 times 6 plus 7 or 3 times 7 plus 4. Either way, 7 has to be one of these three. This is 2 times 6 plus 8, or 2 times 8 plus 4. So this has 1, 4, or 6. This is 3, 7 times 4, or 3 times 7 plus 4, or 3 times 6 plus 7. So this is 4 or 6. Therefore, the remaining digits are 1, 5, and 9. This is 1, 4, 7, or 9. It cannot be 7 here. 2 cannot be either of these, so it cannot be 2, 8, and 9. So this is 1 or 4. This can't be 1. This has to be a 1, 5, 9 triplet here. Yeah, so it was that extra one I missed. 3 times 6. I think this is still the same, right? 9, 6, and 9 works. That's the only one that seems to work well. This is 1 or 4. If this is... that's interesting. If it cannot be 3 times 6 plus 7. So if it's 4, this is 3 and 7. But that doesn't work. Okay. So this is still the same. This has to be 1. Since this... Actually, it's not quite the same. But... This is not 1. We have a 5, 9, 5, 9 pair in box 3, which eliminates 5 and 9 from the rest of the box. Therefore, this is 1. This cannot be 1. This can't be 4 again, because this requires that to be 3, 7. And 3 and 7 are eliminated from that cell, so this can't be 3, 7 plus 4. This is 1. So it must be 3, 8, which would make this 3 and this 8, or it's 4, 6. Well, we have a 2, 4, 6, 8 quadruplet in row 2, which eliminates 2, 4, 6, 8 from the rest of the row. Therefore, this is 5 or 9. That's fine. I think this still has to be the same. Okay. Okay, again. 6 plus 9. It cannot be 2 times 3 because of the 2 here, and actually the 3 here. This cannot be multiplied by 2, cannot be multiplied by 3. If we tried to do it without a 1, the minimum would be 4 times 6, which is 24. So we need a 1 multiplication. So this is 1, which means this can't be 1. This can't be 1. This can't be 3. This can't be 1 anymore. Okay. So this is 1 times 4 does not work because that's 11. Leaves 11 here. 1 times 6 works. So again, you can't have 1 here. You can't have 2, 3. 4 doesn't work times 1. Because again, we tried 4 times 6. That's minimum. Because no 1, 2, or 3 in any of... Or sorry, we're assuming no 1 here. And we're saying 2 and 3 cannot be the multiplication. So 4 and 6 is the minimum here, which is 24, and that's too big. Okay. 1, 6, and 9 work. 1 and 7 with 8 does not work because it can't be 8. And this cannot be 9. It can't be 5. It can't be 2, 3. 4 doesn't work because 1, 4, and 11 work. 11 is not a digit. 1, 8, and 7 could work. This actually could be the case. So this is specifically 1. This is 6 or 8 with 7 or 9. This multiplication... Okay, so this could be... Okay, what are the possibilities? 2 times 3. So this can't be 3. This is 2 times 3 plus 7. That works. 2 times 4 plus 5. 2 times 5 plus 3. And 2 times 6 plus 1, but that doesn't... Okay, so this can't be 2 times 5. So this is still the same. 2, 3, and 4. 2 times 3, 3 times 4. 3 times 4 is plus 12 plus 1, so that doesn't work because of that 1. This is 1. This has to be a 2, which means this cannot be 2, which forces this to be a 2 here. Okay. This can no longer be 3. This is 2, 9. Sorry, 2, 8 with 9. That could still work. It's 2, 9 with 7. That could work. It can't be any of the 3s. So 3, 6, 3, 7, 3, 8 all fail. 4, 6 could be with 1. Okay, so this is 2 or 4. There has to be a 2 or 4 as a multiplication. This is 2 or 4. Therefore, the rest of the row cannot contain 3 or 2 or 4. So this is not 2 or 4. This is 1, which makes this times 9. This is 4 times 5. We have 1, 2, 7, 9 remaining in the rest of row 5, but this can't be 1. Okay. Okay. Strange new world we have here. Okay, well, we know well, we don't know anything actually there. Never mind. One of these is a 4, right? So either this is 4 or that's 4. Either way, this can't be 4. This is 6, so this is still the same. This can't be 4. This can't be 6, though. Okay, that's fine. This is 3 or 4. This is fine here. This 9 means this can't be 9, so this is 5, this is 9. Okay. Either this is 1 times 5 plus 7, or it's 2 times 3 plus 6. So either one of those works. Okay. Okay. Okay, let's clear these. Let's try to Sudoku here. What are the remaining digits in box 2? We have 5 and 9. 9 cannot be here or here. This must be a 9 here. That leaves where's 5? 5 cannot be here, can't be here, it must be here. So this cannot be 1 and 5. Therefore, this is 2 and 3. This 2, 3 pair means... What does it mean? This is 2 times 3, so this is a 6 here. 7 cannot be either of these. Therefore, it must be a 2, 8 pair here, which leaves this as 7. So 7 cannot be here. One of these is 2. This is 2 or 4. This is 2 or 4. The remaining digits in the row have to be not 1, 2, 3, 4, 7. So it's 5, 6, 8, 9. Okay. So if this is 6 and 9, this would be 5, 8, 5, 8. Which means... Okay, so the rest of the column cannot... The rest of the box cannot contain an 8, right? If this is not 7 and 8, this is 6 and 9, which makes this a 5, 8, 5, 8 pair. So 8 cannot be in the rest of the box if that's the case. So this can't be 8. Otherwise, this is 7 or 8, and this can't be 8. So the remaining digits here are 3, 4, 6, and 7. It cannot have an 8, right? So 1's one of those two. This can no longer be 1. This cannot be 4. So So 7 has to be one of these 3 digits here. This is 2, 3. This has to be a 1. Ugh, I need to translate this somewhere else. Hmm. Okay, let's do it here. Maybe that'll be 159, 168, 234, 238, 245, 246. Okay, so let's clear out this. So this is 7. This is 1. These are 5 and 8 remaining. Aha. This cannot be 7. This can no longer be 1. Whereas the 1 in box 7, it has to be here. So this is 1, which means 2 cannot be any of these. In fact, we have a 2, 3, 2, 3 pair. This is 1, 5, and 9, but 5 cannot be here. So this has to be 1, 6, and 8. So therefore, this can't be 6 because of that 6. So this is 8, this is 6. That means we have 1, 6, 8 here. We cannot have 2, 3, 8. We cannot have 2, 4, 6. It's either 2, 3, 4 or 2, 4, 5. Either way, it's either 3, 4 plus 2. Right? So here the possibilities are 3 times 4 plus 2. Or it's 2 times 5 plus 4. Either way, the 2 has to be one of these 3 digits. 9 cannot be here. 9 has to be one of these 2. And 4 has to be here too. So this is 3 or 5. So we have 3, 5, 7, 9 triplet. This can't be 9 though. This can't be 3 because of the 2, 3 pair here. Therefore, we have a 5, 7 pair in row 7, which eliminates 5 and 7 for the rest of the row. So this must be 8, which means this cannot be 8. Which means in box 6, where is the 8? It must be one of these 2 cells. So therefore, this cannot be 8. This is a 4. So this is 2 times 8 plus 4 to add up to 20. This can't be 4. This is 7. So this must be 3 times 6 plus 7. This can't be 3. Okay, wait, yeah, this is, these are the 14s. So this is 8. This is 7, so neither of these can be 7. Where is a 7 in box 6? It cannot be here anymore. Can't be here, can't be here. It must be here. So this is 7, which means this cannot be 7. This must be 8 to add up with 1 times 8 plus 7 to add up to 15. This can't be 8. This can't be 3 because of this 3. This is 1 times 8. We have 3, 4, 6, and 7 left. It cannot be both 4 and 6 here. If this is 4 and 6 to add up with 1. If this is 4 and 6, the problem is that makes this a 3, 7 triplet here. So it cannot be 4, 6, and 1. It has to have a 2 here. So this is 2, and it cannot be 2, 8. Sorry, 2, 9. 2 times 9 plus 7 because the 7's here. So 7 has to be here. This is 2, 8, and 9 then, which makes this 9. This is then 2. This has to be 1 then because of that. This can't be 8 or cannot be 8 or 9. So this is 9. This is 2 and 8. This can't be 2. This has to be 4 and it cannot be times 3, it's times 2. That's 8 plus 5. So this makes that a 7. That makes this a 7. This can no longer be 7 here. Oops. This can't be 7 here. This 2 means this can't be 2, so this is 3, which makes that a 2. That eliminates that from being a 2, so this is 4. This must then be multiplied to 10. So this is 2 and 5. This can't be 5. This can't be 5. This can't be 7, obviously. So we have 2 and 5 here. This 2-5 pair eliminates 2 and 5 from the rest of the row. This can't be 5. This is 8, which makes that a 5. This can't be 9 because of this 9 here. So this must be 3. This must be 9. This 3 eliminates that 3, so this is 4 and 6. This can't be 4 here, so this is a 6. This can't be 4 or 6. It's a 3-7 pair then. This 5 eliminates that 5, so that's a 6. These can't be 6. This can't be 5 either because of that 5, so this is 9. This is 5, which makes that 9, which makes that 5. This 8 eliminates that 8, so this is 2, this is 8. This 7 eliminates that 7, so this is 3 and 7. This 9 eliminates that 9, so this is 5, which eliminates that 5, so it's 2 and 5. And, yeah, I messed up earlier. Apologies. This can't be 7 because of this 7, so this is 2. Which makes that 7. This 2 eliminates that 2, so this is 8 and 2. This 6 eliminates that 6, so this is 3 and 6. We have a 4 and 8 remaining. This can't be 8 because of the 8 in the column, so this is 4. This is 8. We have 3 and 9. This can't be 3, though, because of that 3, so this is 9 and 3. Oh, man. I wish I'd gotten it right. This can't be 1 or 9. Sorry, this has to be 1 or 9 here, so this can't be 1 because of that 1. So this is 9, this is 1. That leaves us as a 4. And we have 3 and 6 remaining, so this is 3 and that's 6. Ah, that was bad. Yeah, I missed that one factorization. Anyways, that's that solve. It probably would have been quicker. Yeah, it was pretty straightforward once you got the factorizations correct, but the problem was getting the factorizations correct, and I did not do that. Anyways, I hope you did a better job getting your factorizations, and I'll see you next time on Frank Puzzles. Take care.